that you have not emailed me about, that you're concerned about. How many don't have their textbook yet? I'll just say this, not their textbook, but their, access key. No access key, okay. All right, you gotta email me if you don't have your access key, because that means you can't do your assignments. I don't know you don't have your test out key, or you have not have access to you have not purchased it yet, it's a zero gonna be there. So just please make sure you email me and keep me up to date on where you're at with that, so that way I can see that and I can make note of that, and then we can make accommodations. You can't make accommodations if you don't tell me you don't have it, and I don't see the work being done. That's the only way I don't know. I mean, there's another way I can know, but I'd rather you tell me you don't have it yet, so that way we can try to make some adjustments.
Mm-hmm.
Anything else? Any other issues? All right, so we'll go ahead and get started. This lesson today will be, first of all, wait, let me pull this. Let me do this first. I tell you guys to do it, so I should do it. And what I'm referring to is looking at your, can you see this? Okay, good. This equipment sometimes. All right, so you'll see what I see. All right, so any questions about the assignment? I had some students say, of course, because of that access key, which is gonna cause a problem, because that means we're gonna be getting further and further behind until you get that access key. But either way, if you email me, you should be covered. If you don't email me, you're not covered. What was due Friday?
Exam,
The exam and the
primary
evaluation.
assignment, and week 3 discussion.
Right. So if we got those three, we good. If we don't have our access key, we ain't good, because exam 1, you gotta have your access key to do exam 1. And anything going forward, that's a test out, right? All right, so we're good on that. No questions about the exam if you have taken exam 1. Any questions, anything you saw that was not okay, or you struggled with? I have to know these things, because if I don't ask, you guys are gonna tell me probably in the email. If I don't get an email, I won't know. So I don't know if you don't send me an email about something. Yes, sir.
I didn't see the discussion, bro.
The discussion?
Yeah, what that was it?
So the discussion?
You got added on to it at the end somehow. Did you see it on the dashboard? You got added on.
They added it on?
Yeah, it's at the bottom right here. Like
Oh no, it's always been there.
I already
I
did
didn't see it before. When I
No.
first logged in, I didn't see him. I
Yeah.
had to look into the grade book and then click on it into the
So
grade
you
book.
might be 100% right about that, because they were having problems, and that's the other thing I'm dealing with, is that they have not, because of this new integration, this new Blackboard, there's a lot of things that they're finding out, and I'm not privy, because I'm not a full-time professor. I only come on Saturday, so I don't get to hear this until, and that's why I ask the students, when they come in, are they dealing with something, are they struggling with something, is this not obvious, so that way I can give it to my superiors. If I don't know that, I can't tell them that, you're gonna continuously struggle, so it's easier to email me when you run into these kind of problems. Hey, Professor, I don't see the discussion link, so that way I can go look at it, just one second. I can go look at it, and if I don't see it there, or I go to the student preview, because I have a way of looking at it the way you do as a student. If I don't see that, then that's easy for me. I just tell them, because you reported it, I just let them know, hey, that's not there. So I can't expect you to do something that's not there. But if I gotta know that, because if I don't know that, how can I hold you accountable for it? But you gotta tell me. If you don't tell me, then you're accountable. If you see something, or you don't see something, let me know. Or if you, in the case here, you might not even know it's there.
Yeah, I ain't know.
Yeah, that's what I'm saying, like you're asking, I didn't see the discussion, so I can relate to that. You know, I've been places and things and I haven't seen something and I just assume, yeah, somebody forgot something, but I would raise the question if I know that's part of my responsibility. I would say, hey, in the email, I don't see this. I don't have a problem with that. So, do you see it now?
No.
All right, so scroll down, all the way down. Look at that class discussion. All right, I'm gonna show y'all this. Have you all, who has not done the discussion yet? 1, 2, that's it? Okay, so.
Mr.
That's
Edwards?
required every week for 5 weeks, we gotta do the discussion. So it's gonna be in the same place, it's not gonna move, but I'm glad you pointed that out.
We need to log into
Yes, sir.
I did the binary game and assignment in the exam, chapters 1 and 2.
Okay, good. But you have not done the discussion.
I think so.
It's the answer 3 questions thing.
Yes, I have.
You have done that.
Okay. Yes.
Okay, good. All right. Let's see here. Any other questions? We're gonna go ahead and get started. Yes, sir. What's your name?
You need to log in to
So we'll go ahead and get started, but we gotta get the preliminaries out the way.
do I have
So
to?
that way we can move forward. So,
Excuse me, sir. Where's the syllabus where your email is?
Please?
with the syllabus, okay,
Where
just
your
1
email
second.
is.
All right. So these are the kind of questions that we need to address. And also they could be in the email. You can send it to me in email. All right, so we're looking for the email, my email.
How do you type in the password? What are you typing? The email and the. Okay.
See that?
Yeah, I see it.
Everybody see that? That's what my email is. It's under the syllabus. You were required to go over all 3 of those to pass that, no-show. Okay? But I know things get missed, so I'm not tripping on that. I'm gonna answer the question, so that way you're satisfied, you know, going forward, you know where the information is. A lot of times, I'll say, look in your syllabus, and I know sometimes students don't get to read that, or they skim over that and say they've done it. That's why we require you to say the 3 questions, part of the 3 questions for discussion. But of course, if you never get to the discussion, you can't even answer the question. So, I'm showing you that. That's there. But if you need my email address, I surely will give it to you. I'm just going over that because there was a question raised by that. And also, while we're here, in case I did not go over it, in case you did not go over it, you asked, these are all the assignments and what the percentage of the grade it is. So if you pay close attention to the higher numbers, typically that's all your chapter exams. And then the next one is your test out assignment. So again, that's very crucial for you to have to do your work in this class. All right, any other questions? All right, so then, we'll go ahead to lessons. So the first place you should be going is to your lessons. And then we are on week 3. It's a binary game. I already went over binary, unless you have additional questions at the end of last class about how to do the binary. So you should have been okay with that piece of it. And exam 1 and exam 2 were due. So that means we're probably on lesson 3, or we're right about lesson 3. So what I do is from the PowerPoint, right? If it'll come up. So computing devices. So we're gonna starting hopefully next week when we don't have as many questions because people have their book, or we might have more questions once you get your book navigating that. But until we can get there, it's hard to get to the actual lesson for that week because we gotta do a lot of the admin stuff, answering all the questions and things like that, which is fine with me, but you get to do this anyway, so I don't like to keep repeating the lesson. I don't wanna bore you. I wanna make sure I do address your concerns and get you to getting your code and working, so that way we can move forward. All right? So this chapter 3, all right, so computing devices. I think we touched on this a little bit, but what are computing devices? What do they consist of? Not everybody at the same time.
Desktop, notebook, laptop.
Smartphones.
Output.
Hardware and software.
Oh,
Just-
everybody now. Okay, good.
Desktop.
Huh?
Desktop.
Desktop, yeah. So what's the point? There you go, the key term. So what do we typically, what computing device is the most common computer device amongst these here?
Desktop.
Smartphone.
I would say the mobile device, because most of you right now, you may have a desktop at home, but we spoke to this last time, you can't carry that around. So it's gonna be typically at your home, so as far as going home, you're probably gonna work on a desktop or even a laptop more so, but if you go away from your home, you'll usually have one of these 2 items because they're easily portable, you can carry them around, okay? So I would say the mobile device is the most common device, because pretty much everybody right now has a cell phone, right? In their pocket typically, and that's how you communicate, all right? So this is what that is, you know the definition, the desktop, basically it's not mobile. Your laptop and your notebook are typically mobile, and of course your mobile device is your smartphone. Alright? So this, we talked already about this last class, so I'm gonna kinda skim over this, because we've already talked about it, so there's no need to talk about it again necessarily. So, you see this desktop contains these things, right? They're all also in, so what's common? Input? And what's input?
Monitor, keyboard, mouse, speakers, video camera.
Monitor is an input device?
No.
A monitor is an output device, okay? What about speaker? Output device. Video camera.
It's an input and
Huh?
output.
And you can have, they can be both also, yeah, you can have both. But not all of them are both. So you just gotta know the difference between what's output, test purpose, and what's input. What devices are those? If you don't know for sure, you might wanna brush up on that, alright? Alright? So here's some of the advantages and disadvantages we already talked about. They say easy to repair. Is that true? Is that easy to repair? Yeah. Desktop, yeah. So desktop is probably the easiest one to work on, but why?
You can switch out the parts.
Yeah, and also, anything else as far as what you think repair, what else? It's bigger, and it has things that you can easily open and see what's inside. So these things you're talking about replacing, you have to be able to see it to replace it. So there's a way you can open this desktop, and you can pretty much see everything in there. Okay, so that makes it an advantage versus try to work on a smartphone. Have any of you ever done that? See, so that's almost impossible, because first of all, if you break the seal on a smartphone, you've already voided the warranty. So if you have any kind of warranty on the phone, by breaking that seal, you've just voided it by trying to open it. I've never seen nobody open a smartphone either, by the way. And as far as laptop and desktops are concerned, I change out stuff in my laptop regularly. You know, and when I say regularly, when something goes bad, like my hard drive. If my hard drive is bad, I can open that laptop and go up under the keyboard. Usually it's up under the keyboard, and you just go in there and you take it out. It's different for different manufacturers, but most of the time they're under the keyboard. Yes, sir.
Can you change the battery in your laptop?
Yes, you can
Certain
change.
ones or just all of them?
You can change certain ones. CMOS.
Okay.
Y'all know what
I
CMOS?
think mine went out, I'm not sure why.
Well, so you know if it'll go out, that means it's not gonna cut on.
Yeah, it's not getting the power. I think it might be the battery.
Yeah, it might be the power supply too.
Yeah.
So, but you can change both of those, but with power, it's just an adapter or the battery in your computer. So your laptop has a lithium battery, you can remove the lithium battery and order another lithium battery, and that might be your problem. Lithium battery is just
Probably
gonna,
what it is.
huh?
It's probably what it is. I used it for about 7 or 8 years.
Oh yeah, so that's what it is. I can almost guarantee you it's your lithium battery. I had the same problem in that
How
laptop
much
up
those
there.
cost? How much do they cost?
They different depending on the year. You said 8 years, so that's an older computer, or older laptop, so it's probably gonna be cheaper. And that's what you gotta look at when you start talking about replacing different things. The newer something is, that typically if something is fairly new, you really don't have to replace anything for the most part. It's just when it gets a little older. When it starts getting a little older, good one. When it gets a little older, then it's gonna eventually wear out just like anything else. And when it wears out, it has to be replaced. If you're smart enough, just by, because I'm telling you, that lithium, I'm still using that computer. That computer's probably, that laptop is probably 10 years old. But I've replaced parts. You know, I've replaced the lithium battery in it because it wouldn't it wouldn't hold a charge when I plugged my adapter in. It wouldn't hold a charge unless I had the power plugged in. I took the power out, it immediately went away. I knew that was my lithium battery, not charging back up. So if you get in that and you see that, that's one of your things that it could be. Now, I talked about a CMOS. CMOS is the battery that sits on the motherboard, okay? If that goes bad, typically, when you go to cut your computer on, it's not, if that battery is done, and I've not seen them typically go bad. They take a while. The CMOS on your motherboard takes a while to go out and start going bad. Your lithium battery will go out before your CMOS go out. So if you're having problems with your computer, you can't get it to come up, that's the first thing you wanna go with. The cheapest way also, that's the cheapest way. The lithium battery, replace the lithium battery. They different prices, so you gotta look it up. How about RAM? Anybody? Anybody? RAM. So, when you buy a computer, RAM is random access memory. It's the storage that keeps things temporarily in your system. So, if you bought a computer that's 10 years old, the RAM that's in it is probably, I'm just gonna call it 4 gigabytes. Okay? Is that good or bad?
Bad, bro.
In this time, because it takes so much for RAM, takes so much RAM to move around, or to be able to move around with all these active web pages and all this stuff, that requires a lot of memory. And the bigger that RAM is, the more that RAM is, you see smoother transitions in your computer when you go from this to that. You won't sense a whole lot of slow time, or your computer's not real slow. The more beefed up your RAM is, the more smoother your computer will operate. So, if you bought a computer that has 4 gigabytes of RAM at that time, you can update that, you can beef that up, you can replace that. Okay, how much can you replace RAM? How far can you go up in replacing RAM with your computer? Anybody know how to know that?
Motherboard
Specs, thank you. Your specifications on your motherboard will tell you how much RAM you can put in or on your motherboard. You gotta know that, because if you try to update your computer to, let's just call it 32 gigabytes, and the manufacturer or the specs on the motherboard don't allow that to happen, you just wasted your money. Well, I won't say wasted, but you can't use it
Use it
on that particular computer. You can't use it on that, but it's best to know before you go. So that way you know what you're looking for, you know what you need. And the same thing holds true when you buy in software. We'll get to that in a minute. But right now, let's go backwards to the computing devices. We talked about the advantages of that, which is what? What is this called? Desktop. So the advantages and the disadvantages of the desktop are these things. And it says desktop requires AC power. What does that mean? You gotta plug it in. It has to have a power source. It's not like a laptop or a notebook or a mobile phone that you can charge. You can't charge a desktop. So that's a disadvantage. And also it says not mobile. This is what? This is a laptop, okay? Lighter, we talked about these things, wireless networking. You don't always have to have wireless networking, but you can because it's a mobile device. You can move around with it. And you can also plug it up, and you can also attach it to the network. It can be a wired connection. How did it do that? How does it do that? No, if you just plug it in, to plug it into what? I guess I'll ask that question. Okay, all right, so the cable, Ethernet cable allows it to be wired. What allows it to be wireless? Wireless adapter. That's already built in. There was at one time you had to buy a wireless adapter in order for your desktop to actually connect to the internet, to the network, okay? Because they didn't have the communication piece. That's a little bit of the history behind that. But anyway, so it can be wireless or wired. It's battery powered. We talked about the kind of battery, lithium battery, some of the disadvantages. Why would it be difficult to repair?
Small.
It's smaller and it's not as big, like we talked about the desktop being a little bit bigger. However, the laptop, everything is up under the keyboard. No matter which laptop you look at, most of the time, you can pry, if you know what you're doing, you can pry the keyboard up from the laptop surface. Well, in this case, there is no prying up of the keyboard because there's no way to pick the keyboard up from the surface. They have these screws on the back that are attached to this whole top unit. Because it's an older design, you just unscrew those screws, and of course you gotta have a special skinny, small head screwdriver and undo that, and that's how you get to all the internal part of this laptop. When I first brought this laptop, even though I'm in the IT field and been for a while, I didn't pay attention to how difficult it would be to work on it, because I brought it based on price. So, whenever you out in the market trying to buy you a computer, a laptop, a notebook, whatever, sometimes the thing we miss the most is how can I work on it? Because I'm telling you, if it's harder to work on, it's gonna cost you money if you can't work on it. Just like a Mercedes, just like a BMW, just like any car now, but more so because they're special, they have special tools and parts to fix Mercedes and BMWs, they're gonna charge you more to get it fixed. So if you have this computer, you want to update, like we just talked about your RAM, if you want to update your RAM, you have to open that up. To get into, if you're gonna do it, now somebody else is gonna do it, they're gonna charge you for that. Because the average person is not gonna just open their laptop up and start replacing RAM and hard drive and these kind of things. So, difficult to repair, yes. Phone, forget about it. Smartphone, you can forget about it. You just go ahead and send that to the manufacturer, and by that time anyway, it's designed, you're gonna have to buy another one. Guess how much that's gonna cost you? A new phone. You gotta get on a plan. And then yeah, and then they get you for what, 3 years, 4 years, or whatever. So you end up sometimes, in some cases, just outright buying the phone. So anyway, so that's the laptop. So this is the tablet or a notebook and a smartphone. These are the computing devices we're talking about now. Look what it says about the advantages. What does this mean? Integrated hardware.
Isn't that shorthand for touchscreen?
Kinda, yeah, you right on it, yep. So anytime something is integrated, then that means it's kind of all in one kinda. You know, like for instance, you ever heard of this term, integrated circuit? Integrated circuit, what does that mean? Well, your motherboard is an example of an integrated, that has an integrated circuit on it. Why is that? So what you're really looking at, no matter what the device, but the better way to see it, we're gonna use the laptop as an example. How I know that this motherboard and what this motherboard looks like as far as an integrated circuit is concerned, I have the ability to have power plugged into that. The motherboard affects that. I have an HDMI cable plugged into here so I can see it on the screen here. The motherboard has to do with that because the HDMI circuit is on the motherboard, okay? There's a USB, there's 2 USB, 3 USB ports on here. All of those are affected by the motherboard. Those are integrated, that's the integrated circuit piece of the motherboard. Okay, so when you talk about integrated hardware, that's what we're talking about, stuff like touchscreen and all that. So, but you probably will hear integrated circuit more than you will hear integrated hardware. So that's why I kind of talked a little bit about the integrated circuit. That means your USB, your power, all that's going to be on your motherboard. It's going to be on your motherboard in order for you to use it on your, in this particular case that we're talking about, on your laptop. Same thing with your phone. If you were to pull out your phone, you have power. You have mainly power. You have ability to put somewhere in here. You can put a you can put a SD card, a small card to hold your data. Because how big would this be for the most part? When you buy your smartphones from any company, whoever it is, right? They offer you plans, and the size of your phone matters because that's how much you're gonna pay. If this is the highest, as far as size is concerned, I would just call it 128 gigs, let's call it, versus a 64 gig, versus a 32 gig, versus a 16 gig, versus an 8 gig. You can get those, but you won't be able to do a whole lot with them because everything is dependent upon how much space you can hold. Because guess what we're doing nowadays? Why do I need all that space?
Download.
You download, we take pictures, we download videos, we're doing all of that. That requires space. And because it requires space, when you go to purchase a phone and you got this great deal for an 8 gigabyte phone, but then you can only hold 10 pictures on it. Right. And then you realize, oh, that wasn't such a great deal. Right? So you gotta understand that, especially if you're in the market of buying another phone and you already know your phone filled up really fast. What's the way to avoid that? What's the way to avoid filling up your phone? That's one.
Get a different phone.
Uh-huh.
Get a different phone.
That's two. Say it again. Download stuff off the computer. A lot of times, the biggest thing we miss is taking the stuff off. We just talked about repairing, updating your stuff. What about removing some of this stuff? Because when you remove videos, pictures, what have you just done? You freed up some space. So you don't necessarily, if you do that well, you don't necessarily have to get cloud storage. Don't have to, but you can. But what happens with cloud storage? Eventually, if you don't do something with that, you're gonna have to get more cloud storage. You're gonna eventually run out, and these days and times, you're gonna run out of storage space faster than any time, unless we go to something else, which I think they're not gonna go to more of storage. They're gonna go to less storage, devices and technology that takes up less storage. So you gotta understand that. I want to show you something. Let's see.
If you can use your contract, and you can go to the bookstore and give it to you today. Put like the number on the receipt.
And I'll do this from time to time so you can understand better. Anybody can see this? What's this? Hard drive. What kind of hard drive? What kind of external?
Micro external.
This is called SSD, okay? Versus a hard disk drive. First of all, I wouldn't carry the hard disk around because it got to be hard disk. Typically, it has to be installed. But the newer technology coming today gives you this. Can anybody guess how much storage this is?
1 terabyte.
1 terabyte. That's the common standard. You can get them in any size for the most part, but this is a 1 terabyte. I DJ pretty much all my DJ music. It's not just on this, but pretty much all the music I have sits right on here, and that's probably about 30,000 songs. Just on this.
What's the pay for that one?
$30.
That's not bad.
Or 60, 1 or 2. I bought it a while ago. But my point is, when you have on your computer a lot of stuff and it's getting full, it'll start acting strange on you also. That's the other thing about storage. If it's at its capacity, it doesn't have no room to operate. If it doesn't have no room to operate, it's gonna start operating weird on you, okay? You're gonna start not getting the same performance that you used to get when you first brought it, when it didn't have nothing stored on it. So you gotta be in a frame of mind to always, when your computer start acting slow on you and go, I need another computer. You might need another computer, but you're going, unless you got $400, $600 to go ahead and spend, I would spend the 60 on the external drive and just offload some of my stuff onto that. And that'll save you a lot of money, okay? And then of course you gotta do the stuff like scan this and defrag, which helps with the performance, things like that. But also what helps with the performance is removing some of that data, some of that clutter. So you, in combination of all three of those things, you'll have a computer that will still perform well for you and you won't spend all this money. Here's another one. Everybody know what this one is? Huh? This is a So, yes, but this is a different type of USB flash drive, okay? This USB flash drive has a different adapter on it. It has a, what is that? So this is a C-type, right? And this is a regular USB. So this is not your normal go to the store and buy. Oh, you can go to the store and buy it, but you know you need to know what to ask for. This is for all your phones out there, right? If you got a phone, your phone has typically what on it? Not all phones, I ain't speaking Android, but I don't know what they got, but I'm not pro or against it. I don't care. It's just how it's my mind. So what you saying? So your phone, that's what we're talking about. So, your phone has what? Typically on an Apple phone, they have a Thunderbolt. But, if I wanted to take my data, how would I take my stuff I'm storing? I'm storing stuff on here, right? Everybody will agree, right? So how do I get my data off of here? I don't want all these pictures I got on here no more. I don't want all these videos I got on here no more. How am I getting them off? You can transfer it, but typically what do we normally do? Just let it build up? Well, what do? You delete it? What about if you, No, go ahead, say what you gotta say, that's what this class is about, discussion. You send it to a person, now you fill in their phone. Get it off yours, right? But guess what though? Did you know if you send something to a person, you still retain it too? Right. So now you complicated the issue by giving somebody, I'm just gonna call it, excuse me, giving somebody your junk so they can have it. Now you got the junk and they got the junk. But that's how data propagates itself. And that's an important lesson because on the internet, if you start talking about a worm, a Trojan horse, a lot of people don't understand all this, but the way it propagates itself is just what you just did, but on a network. So you go open a file and it has a virus or something on it, and you open it. Once you open it, guess what? Then you take that email, you give it to somebody else, you share it with somebody else, they open it, now they got the problem. And so our network is based on the user. So we said this earlier, and I want you to keep remembering this. People are the most important part of any organization, any information system. And the reason why, because we're the one pushing that button and sending this virus to somebody. Not on purpose, but sometimes you don't know. And when you send it to somebody else, they get it, they open it. Same thing happens on a network, and on a network, that happens so fast. So that's why you saw my hacking and being responsible. The main person to get is the user, get the training you need so you can understand how that works. So back to the phone, how you get it off besides sending it to somebody else. this device I brought, right, has this adapter on it, it's USB on one side, right? And it has this port here, this on another side. So, if I want my data off this phone, I take this, put it in my phone, and then all I gotta do, it'll come up, the application will come up, and just transfer all the videos, all the photos, all the whatevers to this device. Did I tell you how big this device was? 1 terabyte. So this piece here, this little thing I just stuck on my phone, is 1 terabyte. So I can hold up with 1 terabyte. I'll probably never reach that. And then what I can do is, once I have it on here, because it's USB, now I can just download it to a bigger drive or something on my computer. Now everything is off my phone. I still have it, but I don't have it all cluttered on my phone. I'm gonna clutter my computer up, but that's okay, because I can get a bigger hard drive for that as well, a bigger external drive for that as well. I got a 4 terabyte external hard drive that I hook up to my computer, and I'll probably never fill that up. I got movies on there, I got videos, I got everything on there. Yes, sir.
Would that external hard drive connect to your phone too, if you had the right plug?
Yeah, if I had the right plug, I just change the plug out, and it will hook to my phone. But I try to keep them separate, you know what I mean? So that way I have that, and then I do a backup. I always do a backup of my big drive, my 4 terabyte drive. I always back that up to another 4 terabyte drive. You see what I'm saying? So as it's constantly increasing, at least I got a backup for it. Because if something goes wrong with that, I'm dead in the water anyway, because now I took all my data, put it on one device, and now I can't even use that device. So you always want to have a backup. So that's the lesson here. That's kind of what's important. Where we at here? This is the touch screen here. So yeah, so these are some advantages. You gotta know these things. So when you're using the thing, you know what you're dealing with. And again, sometimes something as simple as spreading a virus can happen just like that, because we don't think constantly about what we're sending. We don't even know what we're sending, because we don't know if it's infected at all or not anyway. So that's the hard part. So hopefully you become more educated by taking this class, and you know going forward what you need and what to do to help you, okay? So, research. So you can do this. We're not gonna do this necessarily, but so researching computing devices. Now, what does that all mean to you? Now that you got this knowledge, all right, now I'm gonna say data. You got this data, how you gonna use it as information? Because that's all data, the difference between data and information is anyway. I just gave you a bunch of data. Now, the information part, when I explain to you how to use it. So now it becomes to you for information, how you use the data for the information you need when you're looking for a computing device. What are you looking for? Do you even know? Do you have a certain amount of space you need? You know, these are the things here. So in this activity, typically we would do that and research computing devices. Why would we do that? Because what kind of job do you have? Anybody here in the science field? Anybody in here that has a job that requires a lot of computation, like accounting, things like that? No? Are we all students?
Being a daughter.
That's the job, student? Being a daughter. Okay, gotcha. All right, so I'll ask this question. When you're looking for a device or computer to use, what's the first thing you look for? Be honest. Huh? PC? Okay, what's so when you look for PC, what are you looking for? Specs, you're looking for specs. Because now what do you look for when you buy? When you said specs, she said PC. RAM, you look for RAM. For the game, PC, memory. So, none of y'all look at price. I said, what's the first thing you look for? At the end. Well, that's good. That's good because guess what? That's what it comes to at the end because once you find out you need for what you're trying to do, you get X amount of RAM. Your price is up there now. Now you gotta settle because your money and your checking and your savings are agreeing with each other. And when you look at it, you go, well, you know what? I can't get that. So now I'm gonna have to cut down on stuff. What are you gonna cut down on? Are you gonna cut down on more RAM? Are you gonna cut down on storage? Are you gonna cut down? You're gonna cut down on specs. Specs are specs. But that's good to know to look for the specs because if you got the state of mind to look at the specs, you know what your limitations are. If you don't look at the specs, and like most people, like my daughter just bought a computer. Well, actually, it was a notebook. She thought it was a computer. I said, based on these specs, you don't have a computer. You got a notebook. And why did I say that? Yeah. Yes. And you can't do but so much because they don't give you so much unless you spend a lot of money. She went for price, thinking that she got a computer, and come to find out that's not what she had based on her budget. Yeah. So really you really want to understand your specs. That's really the first place you really want to go when you're trying to buy something. Because at least you know what you're gonna get for whatever the price they asking for. So the first place you really want to go if you're interested in buying another computer or any kind of computing device is look at their specs, and they all got a specs page. You can look up the specifications for pretty much anything that's made, that's manufactured. You can look up the specs. But it's important in this field because it's so much different stuff out there, and it changes so much and so fast. You know, 4 years from now, what you brought is already obsolete when you brought it. You know what I mean? Program, all of that. And so if you buy something with specs that doesn't have storage, as far as programs are concerned, you can't put but so many programs in there. Then now it's almost like your phone. You got a bunch of apps on your phone now, and sooner or later, you're gonna run out of space to see those apps on your phone. I mean, if you look at some of these apps here, I'm telling you right now, already that's a full screen right there. That's just one swipe. One swipe. Okay? It depends on how many dots you got down there. Will determine how much you swipe it. To the left or to the right, but it doesn't matter. Okay? So you need to know that because after a while, it'll tell you. Some of these devices that you install, download, whatever, on here, they have a feature that will turn it on. So that means it's eating up your battery. Okay? So if you got a screen full, 3 screens full, and you go to your settings, you can look and see what's turned on. And you can shut, if you don't use it, then either shut it off or delete it. If you haven't used it in the last 3 months, that means you don't need it. You brought it, you downloaded it for that particular time, and if you need it, that's fine, just use it. That's fine. But do something with it, delete it or turn it off, either or. But that was part of this activity, researching a computer, because people have different needs. But you need to know your specs, you need to know on that specs how much RAM, how much storage, all these kind of things. Just make sure you take a look at it. If you don't do that, practice it. Just test it out and look at it and see what is all there. And you'll see, it'll open up a whole other world for you. All right? How a desktop, laptop, mobile device is similar. How they're different, we kind of already know that. What kind of tasks are best done on each kind of device. Yeah, there was a time when these kind of first came out, I'll say. People were trying to do their application, their FAFSA, the job application, whatever. And it was almost impossible to fill out an application on a smartphone. It's still kind of hard, to be honest with you. What changed that? Anybody?
Screen size.
Well, then now I don't have a smartphone no more. So you gotta make a decision, right? How am I gonna keep my laptop and fill out this application? That's gonna be hard to do. But we'll get to a point in this class where we'll start talking about web designs and web pages and the advent of becoming more interactive. Web pages have become more interactive. And so because of that, the people that design the web pages, they design them with the smallness of a smartphone in mind. So they program it, they code it, so when you pull it up on your phone, you don't see that, you don't know that, but the person creating the web page that you're trying to go to that has that application or has that, that application is designed, they made it where they knew it was gonna be displayed on a smartphone. So you pull it up versus back a little while back, you pull it up, you have to move the screen around and try to adjust and all of that. Now if you do that with an application, typically it's easier for you to do. And then of course, when you type in the field, and we'll talk about a field, when you type in the field, this is where the touch screen comes into play. You touch on that field, then keyboard pops up. And then you can just type the information in that field. Well, that wasn't always the case. Thank you for web design and people creating that ability to do that, because you always wasn't able to do it. So that's the whole point of technology. It's supposed to grow and learn. You're supposed to learn more and get more, and it's supposed to become more interactive, which brings us to a conclusion on hopefully if you would have done the activity, you would have kind of got a little bit of that. But because you came to class, you got that piece of it, and now hopefully you can connect those dots. All right? So again, different tasks on different devices, but they are making it easier just to do everything from here, because this is a computer, so. So, okay.
There you go.
You gotta get timed out. Am I talking too long? All right, so that was computing devices. I hope you got something out of that. We go to internal components. So I talked a little bit about motherboard already, so that's gonna be part of this conversation. But, so we went from computing devices, right? So every one of those computer devices that we talked about has an internal component to it, right? So I said motherboard, right, on my laptop, right? Does this have a motherboard?
Yes.
Absolutely it does. So every computing device, I said every computing device has internal components. They're different sizes, different things like that. So with that being said, these are some of the things that we're gonna talk about, the most common internal components of any typical computer system. We said, we didn't talk a lot about processor, which we will, but we did talk about RAM. That's considered an internal component. Motherboard, that's an internal component. Power supply, GPU, anybody. Graphics, processing unit, so yeah. So what is that in a nutshell? What's a GPU? Video card. Keep it simple. It's a video card. That's all it is. It's a fancy name for a video card, okay? How about this one? NIC, anybody? Uh-huh. Yep, yep. So NIC is a network interface card, okay? So what does that do?
Unless you connect wirelessly, if that's not integrated.
So there's typically only one thing you can connect to a network interface card. There's only one thing you can connect to a network interface card. What's the cable?
Ethernet.
Ethernet. So that card, the NIC card, is the ability for a computer to expand. Because anytime you talk about a card, you talk about expanding the capability of a computer. So if I attach a NIC card to this desktop, that allows me to get to the internet through either wireless, a wireless adapter, or through a wire, Ethernet. Okay? So those are pretty much the standard nowadays. And then the cooling system, what does that mean? What is that? It's,
So the system does not over.
yeah, but what is it?
Fans,
A
AC.
fan. A fan. Everything in here that has a processor in it draws heat, right? So in order to calm that heat down from working, and I know some of these phones get real hot. I've seen them. And especially mess around, keep it side up and the sun is shining. You might ruin it. So because it gets hot, it has to have that cooling system, and the cooling system is a fan. And every computing device has a fan. You may not see it, like you may not see the fan on your smartphone. You may not see it, but there's something in there that's kind of keeping that cool, even if it's the vents and. Yeah, it's a sort of a heat sink, and it's all computing devices that have to keep the device cool. Although it's this is so small, kind of if you're not using it, it'll cool down by just virtue for the most part. Unless of course you got these things cut on in the background that are being used that causing your battery to drain. Cause I don't know if you've seen this, my phone died real fast.
I just changed up.
Huh?
I just, cause my stuff, cause it was like, it was bad, right? So I had to go to the store to change it out.
Really?
And stuff, yeah, cause it was slow and it was like, it was hot too.
So sometimes you have to, one, probably stay off your phone a little bit, sometimes, and then a lot of times if you overcharge,
Yeah.
so if you always keep your phone all the time plugged in, you're not doing it a favor. What you wanna do, and that's with any pretty much computing device, you wanna let it die down. Naturally, you want it to die down, so you have to charge it, so you can keep replenishing it. If you always keep it full, and you always got it on full charge, the time you need it out of it's used to always being fully charged, so it never had a chance to come down and drain, if that makes sense. It really, honestly, doesn't make a whole lot of sense, but it does when it comes down to charging systems, period. Especially with the lithium battery, you want power to drain out so you can recharge it, because if it always stays charged, once it has to drain, it's not gonna know how to act if you pull it up sometime because it just got overcharged. That happens from time to time. So with that being said, I would say sometimes shut your computer, set your smartphone off, power it down. Give it a break, and then cut it back on. And when you power it down, plug it in and charge it. Don't charge it while it's powered up. I mean, these are some of the little tricks that help with the whole cause. Distinguish between the two main types of consumer level CPUs. Anybody?
AMD and Intel.
Yep, that's them. So what's the difference? I've been around this game long enough to know that AMD was a piece of crap.
I've never used it.
Yeah.
Damn.
That was a while ago. Things, again, it's technology. Things have changed. So, and not just AMD, there's some others out there, but AMD was really considered, yes. And people avoided buying those. Now, Intel was always high in demand and sorted after, but they had a chip before Intel and AMD that they used. It wasn't necessarily consumer level, but it was called RISC, a RISC chip, R-I-S-C, look it up. That's how Apple first, really before they adopted Intel, they had RISC chips in their computers. That's what really made them famous for being a better computer, because of the chip that they were using. The chip that they were using, the average person couldn't get that. That's why you used to pay so much for Apple, especially back in the day when computers were already at a nominal fee. Apple was charging people always like that. But they abandoned the chip because the chip was no longer in production. They couldn't make it no more, something like that. But it was one of those chips that, and by the way, along with their proprietary stuff, programming, what does that mean? Proprietary. So I'm saying
They own it by
Apple,
themselves? So they solely own it?
they solely own it, proprietary, nobody can. If you had to get, I ran into a problem, I had an Apple, and I wanted to hook up a projector to the computer. Well, you gotta buy, you had to have brought an adapter from Apple to connect from whatever I was doing, the computer to a projector. And that's just one case. There's plenty of cases because of the proprietariness that you have to go through Apple, where you can't just buy an adapter because one, Thunderbolt is a particular, you gotta go through them to get anything to connect through that Thunderbolt. And that's specific to Apple. So these are the things I'm talking about. And that's what keeps them, if you will, better, because not that many people, one, have it. A lot of people start to get Apple computers more, but because you gotta get exclusive Apple. Like I don't promote or deny Apple, but I don't have any Apple products except for my phone and my laptop, iPad, thank you. And that's enough as far as I'm concerned, because I still gotta deal with that adaptability thing. So they kind of corner themselves. Now, the difference between Apple and Windows, in my opinion, based on my experience, is that there are more Windows users than there are Apple. So guess what? If you have more people using a product, and we're talking about human beings, so they're gonna make a lot of mistakes.
Get out of here.
The reported mistakes or problems or errors coming from Windows products are gonna be higher because you got more users. That's just the law of numbers. The more the numbers, the more you're gonna have different issues and problems. So for you to say, or for someone to say Apple is better than Windows, let's put the same numbers to the test then. Nobody's talking about that. So I don't care, it's all rhetoric as far as I'm concerned. As far as I care is what you buy. If you maintain it properly, it should last you a good while. But if you don't take care of it, it's gonna be what it's gonna be. All right, so that's consumer level CPU. So anybody can tell me this? How processors execute instructions? Let's see what the level is with that. Nobody. All right, so I'll tell you what I know. It starts off with input, and so once you get input, what's the first thing the processor is going to do? Exactly. So once it receives input, then it processes the information. Then what it do? Then it outputs it, but you got to request it output wise, but the reason why it's processing is so you can ask it to output something. And anybody, anything else? Then you have to have somewhere to store it, which goes back to where we started from with storage. But that's how the computer processor executes that, and it does that in that fashion. Those 4 steps, and that's the actual processing power life cycle, I'll call it that, just for lack of a better term. All right, follow guidelines to reduce electrostatic discharge when working on computers. Why? Anybody know how? Yeah. So when you're working on a computer, because it's an electronic device, it's gonna have a static by you just walking on the floor, and especially if it was carpet in here. If it was carpet in here, you could hear it, like the little static sound. You can hear it actually. And if you go touch a computer, it'll like make a pop, a little pop. And there goes the motherboard. So that's why you gotta be careful. If you're working on your computer, you gotta make sure they have what they call this electrostatic discharge band that you put on your arm. So if you do anything, open up anything on your computer, before you do that, you wanna make sure you got that on your wrist, because that will reduce that electrostatic discharge to your computer and burn something out like your motherboard. So if you're gonna work on your computer, you need to make sure you got an electrostatic discharge. All you gotta do is go to the store and ask them for that, and they know what to get you. And you can have it, and you can freely work on your computer, because then that way you won't mess something up. Identify various types of expansion slots on a motherboard. I kind of did that when I talked about the power, the HDMI, the USB. All those are really expansion slots, right? So for any slot, there's a cable or a card or something that goes in. Like I showed you on my phone, the different sides of one side had a C and the other side had a USB. So those are the kind of things that you can look at and look for, and they go into those slots. Like I put it in my phone slot, the C. So a motherboard, my motherboard on my phone, that slot is a C, so that's the expansion slot, the C basically. On your laptop, I said HDMI, I said USB, power, all those things are expansion slots on your motherboard. And I'll show you that by taking a look at a motherboard some point in time. All right, install a single memory module on the motherboard. You're gonna have to do this, by the way. Put your test out. You're gonna have to install. You don't have to physically do it. It's gonna be a lab simulation of it, asking you to put a single memory module on a motherboard. That's gonna be a challenge, a task for you. All right. Same thing with this piece here. Disconnect a monitor from a video card and remove the card from the computer. You're gonna have a problem. I think there's another lab that covers installing a video card, things like that. It's easy. You just gotta, if you don't know, it's not easy, but if you look, all the labs have a demo. If you look at the demo first, it will tell you exactly how to do the one that's required for you to do for a grade. You got to do it for a grade, but they give you the demo first to look at the same exact what you're going to be doing. So if you study or look at or repeat looking at that demo, you should be able to get it. Because when I first did these lab simulations, I guess about 4 years ago, when I first got introduced to test out, because I didn't read instructions and I didn't have a video for it. I was trying to do it and I was doing it wrong. So I wasn't passing that piece until I got it right. And you're not gonna pass the lab simulation until you got it and you did all the assigned tasks. Yes, sir.
I don't see the demo anywhere.
Open your, do you got your access key?
Yes, sir.
It should be located under any lesson that you gotta do a lab simulation for. that? So it's always gonna be underneath your lesson. So if there's a lab required, lab simulation required, if you open up that lesson, it's gonna give you the video for it. Okay? So it's gonna be a demo, and then it's gonna actually be the lab itself. And it'll say next to the lab itself required. The demo doesn't say it's required, but what it doesn't tell you there is that the demo, I would say, is required, because in order to know how to do the lab, you should be looking at the demo, unless you know already how to do it. If you already know how to do it, fine, you won't struggle with it, you won't spend a whole lot of time on it. But if you get the demo, look at the demo, you know exactly what you need to meet the requirements for passing that lab. That's simple. Alright? Install a video card with an HDMI connector and connect the power connected to the video. They're probably gonna have a lab on that. So some of these things are gonna require, because it says a skill overview. So these are gonna ask how skillful, how proficient you are at producing this end result. Connecting, installing, configuring. That's what's gonna be your test. All right? And if you look at the demo, like I said, you shouldn't really have no problem. You shouldn't be really struggling, because the demo is gonna actually show you how to do it. All right? Some more terms, CPU, we talked about that. That's also called what? CPU, processor, exactly. RAM, we talked about that. Motherboard, we talked about that. Power supply. Bless you. So you can replace the power supply on a desktop for the most part, and a laptop you typically can't replace the power supply, because it's not the power supply on the computer, on the laptop. It's the adapter, the thing you plug into the laptop, or the battery. That's usually the problem. Cooling system, we talked a little bit about that. It's a heat sink on most cases that has a heat sink over that processor to keep it cool. Electrostatic discharge, we talked about that.
No.
The fetch execute cycle, anybody? Okay, go ahead.
Is that when you retrieve data from your?
Right, so first of all, you gotta go fetch. So the process is, how long does it take you asking for something to fetch and get it back to you? That's the fetch execute cycle. How long that takes depends on what?
The system.
Yeah, the speed of the processor.
I was gonna say, is that like,
Say it one more time. Yeah. You can look at, anytime a system is searching, that's for anything. That's called the fetch and execute cycle. Because if I'm looking for something, that means I'm sending a request basically to my processor, hey, I need to find this. So it goes fetching. And when it goes to fetch, once it finds what it is looking for, need, or not find it, it'll come back and say, no results found, or this is what I found. But they do that in a fetch execute cycle in terms of the time it takes to do that. That's why it's called a cycle. How long does it take what I just asked for to go out and find that thing and then give it back to me, or not, or tell me it can't find it? Now, however long that takes is the cycle, the fetch execute cycle. And it's different based on the speed of your computer, the processor, things like that. That processor speed. All right? All right, x86 processors, anybody? Basically, that's the processor in most typical computers, for the most part. That's just kind of keeping it simple. And that's all you need to know. You'll see that if you go in there and look, you'll see x86, and there's one more in there. I can't think of it right now, but there are two processors of that type that you'll see, but most part, that's the most common ones. Now, Remember I said RISC? Advanced RISC machines, ARM processors. Remember I told you, Apple used to use these before they even started adapting Intel. So this chip was actually better, or is better than Intel or AMD. Like I said, I gave AMD a bad name, but in the reality of it all, they have jumped to just as high, if not better. I just brought an AMD system. Whereas one time I wouldn't touch an AMD. If it had AMD on it, I'm not buying that. But they have done way better. They have done way, I'm telling you. And this computer, I do a comparison, and the specs, I looked at the specs for the computer I brought, and it had an AMD chip in it compared to an Intel chip, and the performance was almost exactly the same. So that was my proof of the pudding that I can abandon that idea of AMD doesn't work, or they aren't good anymore. Their performance spoke for me clearer than anything else. So expansion card, that's just basically what I was showing you. That's really called the expansion card also. But that just basically expands the capability of the motherboard on your computer. That's what it does. And I say computer, I should just say computing device, because you can put an expansion card on a phone, on a notebook, a laptop, and on a desktop. Okay? We talked about heat sink, air cooling. That's a different kind of cooling versus water cooling. I don't know a whole lot because I haven't done a whole lot of looking into that, and it never really affected me necessarily, but just know that it's a cooling feature, and there are two different kinds. The air, which is usually done by the exhaust in a system, and the water cooling, which is kind of inside the cooling device that goes through the tube to keep it cool. It keeps circulating water throughout it, so that way to keep it cool. And I don't know about this active liquid heat sink. I'm sure it's just kind of similar like the water cooling thing, where they have in that heat sink, they got water that's flowing through it to keep it cool as well. And I definitely have not heard of immersion cooling, excuse me. But I will. I just don't know a whole lot about it. So I'll talk more about things I know about, and I'll back off things I don't know a whole lot about. So, and I'm not scared to do that, because if I don't know, I'm not gonna try to give you the wrong information.
When will you typically see the water cooling manual?
When you what?
When will you be like typically seeing the water cooling manual?
So you will see it typically in specs. Under the cooling part of the specs, it'll tell you what kind of cooling it uses. And typically it'll tell you it's air cooled or it's water cooled. But specifically, if it doesn't specifically say water cooling, then 9 times out of 10, the default is air cooling. So you would look in the specs and you can see it there. Now, I don't know where to look in the system. Anybody in here? Where would I see that? In a system? But I just know you can look for it in specs. I just don't know. We can look it up. Somebody can look that up and see what we're talking about. Just type it up in your search while we're on that subject. Anybody else?
I have a question.
Yes, sir.
Is it typical to see immersion cooling in like consumer products, or is that more like bigger computers?
It's probably bigger. I'm not as sure because I don't have that much, I'm not versed in that. So we can look that up, because that's what we do in this age anyway. Because the first thing I'll say, hey Siri. Well, she might be hearing me and she might try to respond. But the first thing I do in this age, if I don't know something, I just ask for it. We have the technology, this is the type of time, we got AI at our fingertips. So there's no reason. Give you an example. When I was growing up, I'm trying not to reveal my age, but there used to be an encyclopedia man. And we never knew how, for the life of us, how he carried around all these volumes of books. They were heavy because we had a set in our house. We finally bought a set from him, and they were heavy, but that's where we went for information. That and the newspaper. Now, you barely see a newspaper. I see Atlanta Journal-Constitution is still out in Walmart. I still see them now. But all of that you see in that newspaper now, because of technology, you can just on your phone.
Right.
So as far as we're concerned, as far as books are concerned and knowledge and picking it up, we got a device that we hold in our hand every day, all day. Sometimes we walk into traffic looking at it sometimes. But that's the point, because it gives us the ability to get information at our fingertips, where we didn't have it like that before. We had to do some grunt work, even in college. I didn't have AI, I didn't have a cell phone, I didn't have Siri, I didn't have all that. We had to go to the library. Anybody know about the Dewey Decimal System?
Oh, yeah.
Okay.
Oh, yeah.
Okay, so all I'm saying that is, that's a technology that if you go to the library, I think they still kind of use that, whatever, but I figure they would
That's
still
how you
be.
find your books.
Yeah, see, so that's a technology that they use for, if you wanted information, you had to know the Dewey Decimal System number to find that
You
information.
look on the computer and it's like, tell me the number, point, this.
So the technology has affected that too, but they still use that system. All I'm saying to y'all is that sometimes, you know, I consider myself a low jack sometimes, because I know these things and I try to impart them on you all, even though the technology is gonna be what it's gonna be. It's gonna constantly improve, get better, whatever. But knowing those things sometimes can help improve the technology also. So it kind of goes hand in hand. So, CPU, this is just explaining the definitions. All right, maybe I'll go back to the air cooling. So, the water cooling, it places water, cool, heat exchanger near a heat source. I said that, so as far as where you would see it at, you might wanna look that up and see, where I say the specs, it gotta be in your specs. If it's in your computer, it should be. If it ain't in your specs, then those ain't very well written specs. That's what I was saying. Yeah, immersion cooling, an advanced system of cooling where liquid coolant is in direct contact with the CPU, offering a high heat transfer that quickly reduces the temperature. So, what did you find?
I found that they do have it in like consumer.
It is on a consumer level?
Yeah, but mostly it's like data processing centers.
Yeah, I figured as much because of what it said here. Where the liquid coolant, first of all, when you're dealing with coolant, that's already not something good to have in the hands of the consumer. You wanna have a trained technician, just like in your car, the coolant in your car is poisonous. And you don't wanna just willy-nilly start dealing with your coolant in your car because of that reason. It's just poisonous and toxic to the environment on top of that, so you wanna have that. So anyway, you would consider it being in a more corporate environment, data center, things like that. It just kinda makes more sense. And this part, offering a high heat transfer. So that means it's doing it faster at a higher rate. So that means it needs to do more computers. If it's doing it faster, it would affect more computers faster. So you would say a data center, because that would make sense, you know? So, there it is. What is that? Anybody? Processor, very good. And that processor probably fits on your fingertip, if not smaller now. But they used to be, a processor used to be so big, you couldn't carry it. And then it would be so small in what it can process, you know? So, I mean, we talk about vacuum tubes, if you wanna talk about the history, vacuum tubes and all that represented this, and this fits on your fingertip. So that tells you how fast and that wasn't too long ago, how fast technology is advancing. So what's this? Remember I talked about that, process?
Input processing.
Input process.
Yeah, so that's just kind of a picture of it.
Update and storage.
Input, process, storage. And of course, output, but Alright, what's that?
PCI slots.
Yep. So those are slots located on a motherboard, okay? These here, you see these things here? If I was to push this down and push it kind of forward or tilt it forward, it'll snap in place. You will hear it snap in place. To remove it, you just unhook, press down on one of these things here. See, that one is not fully up right there, if you can see that. Once it's fully up, that means it's in position. You just push down to remove it.
Most times when I push them down, the clips lock on their own.
Right, that's right. Depends on the slot. Some slots you have to tilt it forward. I think the ones in a laptop motherboard, you have to tilt a little forward because of the space. Okay, so desktops are usually straight up like that, and that's a slot. That's what they call an expansion slot. Okay. This is a picture of the CPU, how it connects. So you got, and we'll talk more about that as we get along, a bus. So you have a bus, and buses are, let's see if I can see it. Do you see these lines here? Can you see these little lines?
Yes.
That goes to every device. If you ever look at a motherboard, matter of fact, you can pull a motherboard up, just a picture of an image of a motherboard, and on that motherboard, with all the stuff attached to it and installed in it, the actual motherboard itself has these lines that go from every slot to this, that runs to the CPU, okay? Why do you think every line goes from every slot, expansion slot, to the CPU?
Because it's the central processing unit.
It's a central processing unit, and why? I mean, I understand the central processing, but why all the lines from every little thing, slot and everything? Why is that?
To it.
To control it.
To send signals to it.
To
It has to communicate with everything because it is the central processing unit. Everything has to go through it, so anything that's affected has to see the CPU. So, for example, there was a time when you would install, I used to do installs too, computer installs, in one of my first jobs, right? And so, as an install, the desk, what they used to call a position, a desktop technician, which went around installing the software, setting up the computers, breaking them down, If you set the computer up without the mouse, or without the keyboard, and your thing is set up, and you cut it on, guess what's gonna happen? Yeah, error in the form of a beep. So if it beeped once, that means my mouse wasn't connected. And if it beeped twice, that means my mouse and, no, just my mouse if it beeped once. And then if it beeped twice, both of them are not connected. So that was my sign as an installer to know, oh, I gotta plug the motherboard up and the mouse. Plug them up, computer should about boot up. When I say boot up, what am I talking about?
start.
Boot. So what's the difference? Do you know the difference between a cold boot and a warm boot?
Boot it for the first time.
Cold boot. So fresh start, fresh power on is a cold boot. So then what's a warm boot?
Restart.
A restart, reset, yeah. Okay, so y'all got that. So that's important because, sorry, I'm getting a little dry from my medication. So that's gonna be on the test, knowing the difference between a warm boot and a cold boot. Okay? Now you know that. All right? That's just showing you instructions from the memory, which it has. So when it communicates with the CPU, it knows what to do, what's allocated, how much allocation it is required. The CPU will tell, hey, I need this amount to start it up. And it reads all that information, instructions from the memory, okay? Now, that also will tell you, if you, let's say you go install an application, and the application requires more RAM than you have, what's gonna happen?
It might shut down.
It could,
The program might shut down, or it might just get really slow.
yeah, yeah, blue screen, or it may not install it if it doesn't have the required amount to even accept it, the software, okay? So what'll happen is, it will start running funny, slow, whatever, if it do accept it. So if it doesn't accept it, and you see something wrong, you might get a blue screen. Now, you gotta ask yourself, how much memory did I put in there? And how much does the software require? So again, if you were to go and look at the specs before you buy the stuff, you would know how much it needs. Then you need to ask yourself, how much memory do I have existing in my computer? How do you know that? How do you find that out? System information or settings or stuff like that, and you can see how much is in there. And you can, I'm sorry? I hear you.
Nothing, never mind.
Okay. Alright, so the results came from the instruction from the memory, and then the results, the CP will spit that out and display. See this here? See these lines here? What are those again? Those are bus lines. You see they go from every device, and they end up going from whatever that is, that slot, to the CPU, and that's how communication happens through the motherboard. All right, I talked about that CMOS, which is the battery. They have this thing called a BIOS. And what does the BIOS help you with? Anybody?
Make sure all the hardware around.
Yeah. So when I said I used to do install, and I would hear that beep. Well, guess what? That was this basic input-output system telling me you don't have everything to boot this computer up. That's what it's telling me. And this is what's responsible for that. It sits on the motherboard in the form of a CMOS battery. That's where those instructions are for that, okay? And you'll see it if you open a computer and look at the motherboard. You'll see a little silver, a little round, almost looks like a, like a watch battery. That silver flat looking battery, it'll look like that. It'll be sitting in on the motherboard, almost central, almost real close to the CPU. Okay, and the heat sink. There's a heat sink in there too, and between the heat sink, the processor. Matter of fact, I think the heat sink sits on top of the processor because it keeps the processor cool. All right. Internal computing components. What's that?
Power supply.
Power supply. Okay. Is that an ordinary power supply though?
No.
Yeah. This is for backup. This is a battery. It says it there, battery backup. So you would plug all your computers to this, and basically, if something was to go wrong and it shuts the system down, the battery will keep it up and running. It won't just die. Okay? All right, and that's important to have too, especially in an organization. All right, what is this?
Cooling system.
Cooling system? Okay, so yeah, we can call that a cooling system. So, or i.e. fan, because that's what that really, in the basic knowledge is, because the fan is the component in the cooling system. All right. Now, let's see something. You have some of these, right? And they have a fan on them, but they are video cards. So why would a video card have a fan on it? All you gamers,
Yes.
Pull down.
right, so the video card itself has a processor on it, and anything that has a processor on it has to be cooled down. And especially with videos, because I don't know if y'all ever watched games. I'm not a gamer, I used to play games, but I'm not a gamer. But if you've ever seen people gaming, it's like a spectacle. I mean, the yelling, the shouting, the yeah, get them, and all the noise and behind the gunplay and all. It's just crazy. But it's a lot of action going on there. It's a lot of work going on in there. So it needs a fan to cool down. This is really called a coprocessor. So it's a video card with a processor on it, and we call it a coprocessor. All right? What's that? That's just a diagram to show you how it cools the system down. Intake, and it pushes it out. So it pulls in all the air around it. That's within that cabinet. Then it spits it out through the exhaust, and that's how it keeps the system cool. And that's any of those cooling systems we're talking about. All right? CPU, RAM, we already talked about all of that. Electrostatic discharge. So you have these different positive and negatives that build up. Once they build up too much, then they're gonna discharge on the first thing that it touches. That's why it's called a electrostatic discharge, because these are electrons. I'm not a scientist, but these are minuses and plus electrons. And they have positive energy or charge and negative energy or charge. When they build up too much, then they create this environment where it has to release the buildup of all of those negative and positive electrostatic charges. And that's why you gotta have, boom, when they collide, you get that pop, which you'll hear. All right? These are just the memory jog, just explaining to you about the electrostatic discharge, and it's telling you about the CPU and the volts that it can take, and all the voltage basically that's involved in your outlet and your CPU and your human body, which is why that discharge is important to you, because when you go in your human body to touch that stuff, it's gonna give off that discharge, and if you don't have nothing to receive it, it's gonna blow whatever that component out. Or it could blow it. I don't always have to, but depending on how high of a charge it is, it could do that. But it's safer than to put the wristband on versus not and jeopardize all the components in your computer. All right, so you see him touching that. That's what they're referring to. So yeah, there's a mat as well you can get. I didn't mention that, but I'm glad I have this slide. So you can put but the mat has to be on the computer and on the floor in order for you to work on that, because that'll diffuse the charge. Okay. All right, so they get that build up when you start installing these RAM. So because it's always moving stuff in and out via these connectors. So you saw those gold connectors on the bus, on the motherboard. You see this gold on the end of these. On any card that you put in any slot is gonna have that, and that's where the communication happens. Once you have communication happening, you have electrons, electricity going back and forth through these things. So they're gonna build that positive, negative charge we talked about. It's gonna build that up. All right, what's this called, anybody?
Electrostatic bag.
Electrostatic bag. And as most of your equipment, if you order it from somewhere, like you're gonna replace your hard drive, your motherboard, whatever, it'll come in this bag. Because that will not allow anything electrically to build up on that device. So when you go to install it, if you didn't think about putting your floor mat, your electrostatic mat on the ground, or on your wrist. They used to be a wrist. Now they created these static mats as well. But it used to be mainly reduced to a wrist, because that's the first thing that you use to work on your computer. All right. And they come in different sizes for different things. I don't know what that means. Coffee. So I think actually this is an insulator for styrofoam. All right, we talked about the fetch, execute cycle. Let me get a time check. Anybody? All right, so this is kind of telling you in a more sophisticated, what I explained earlier, fetch, it codes it, then it executes it. It's just a cycle. So it goes back and on and on. It used to be a time that this RAM here used to have what we call, we have what we call jumpers. When you would install a hard drive or something like that, thank God they don't do that anymore, because that was very frustrating. So you would put a jumper on or off a particular address, which is a pin.
I remember that.
Yeah, it would be a pin, and on that pin you would put the jumper on either 1 and 3 or 1 and 5 or whatever you're trying to do, and that was aggravating because I used to carry a sheet around what jumper I need to install it, to do this, to do that. So, but the point is, the technology has brought all of this that you would have done manually. Now in this cycle, it's done on this electronically or automatically, I should say. So, machine language. Anybody? Binary. Thank you. Very good. That's how computers communicate with ones and O's, either off or on, and that's what allows the computer to process in a matter of nanoseconds, microseconds, whatever you want to call it, because it's machine language and it's only 2 states. It only has to deal with 2 states. That's it. Yes, sir. Oh, what? Bathroom, walk down the hall, and before you, once you get past the elevator and go through the stairwell, keep going and look to your left, and you should see it. It's hidden, but you'll see it. So better go down just in case you gotta find it. All right, so machine language, that's the language machines talk in. And binary is the main language. It's really the main only language for the most part. There are some other levels of language, but those change as time. But in this day and time, we mainly deal with machine language because it's the ones and O's, and it's the I guess the easiest one to talk about. So there's programming language, and of course programming language has evolved as well, especially with Unicode. That's a whole nother thing that accepts symbols and things like that, and not just letters and numbers. We had to go there because so many different cultures use symbols as language. So words and letters too. So technology wise, we had to come up and expand to a global, because we are always and have always been global. It's just now computers are really now just catching up to global, you know? So you have a code language, programming language, and that's basically what it does, but it needs a compiler. What is this? See this? Binary stuff? So what takes this statement? Somebody writes this program code to do something, so it takes that data and turns it into information. How that happens, you got to have the compiler between the language, you have to have the compiler to interpret it and make it make sense to the machine, to the computer. And as you can see, those are all zeros and ones. So that's how the computer operates. So that's why we had that lesson in converting, let's call it a number, to a decimal to a binary code. That's how they do that, through a compiler. All right? CPU types, that's that x86 I was telling you about earlier. And it comes in the form of the Intel and AMD. High power consumption, very hot. So that means your fan better be, your cooling system better be up on point, right? Because what's the first thing? Here's another thing. Speaking of industry and jobs and doing your job, as I was a desktop install technician, I would walk into a room and sometimes and feel it's kind of warm in here. What's that telling me?
The computer's on.
Computers are on.
Here's the fans ain't on.
They're on. Yeah. That's why they hot. But what's your first? What should be your first evaluation behind that? Check your fans, because if you're in install, even if it's not your job, because where you work at, your senses are most important when it comes down to computers, because they give off so much heat. And even in the advent of SSDs, solid state drives, which give up less heat, but when you got, how many computers in here? 20, 30 something running at the same time, it's gonna give a certain amount of heat. So if you come in here every day normally and it feels one way, and then one day you come in and it feels a little bit warmer to you, then that's your first sign to say, hey, what's going on with the air conditioning unit? What's happening with that? Check the temperature, go to the wiring closet. By the way, the wiring closet is where all this stuff meets at to keep communicating with the network, okay? And we call this part of it a segment of the network. So if I know that computers are acting up in this classroom on this segment of the network, eventually it's going to affect other parts of the network. So that's why it's important, if it's your job and you come in this room and you feel it a little warm, even if it's a false alarm, if you feel a little warm, check. It ain't gonna hurt you to check, especially if your senses say it's kind of warm, then, or at least call somebody to say, hey man, check the temperature, turn the temperature up, or something, whatever, but typically turn the temperature up so we can cool this place down. Then they gotta find out the culprit that's causing the problem in this room. Because usually you can tell, because now you know the segment of the network is on, now you can identify what computer may be causing the problem, overworking. How do you find that out? It's a tool called network monitoring, and you can monitor every computer in here on one screen. And on that screen, you can see which one is spiking in the usage. And then you address it. You go to that computer, because you can identify what computer it is. Go to that computer, you may have to shut it down, you may have to install something, you may have to do whatever, but that's your indicator as a technician what needs to happen. But your first indicator is your senses that will tell you, hey, it's hot in here, so something is wrong, either the temperature or whatever. All right, so the types of CPU, we said ARM, which is the RISC, and the x86, which is your Intel and your AMD chips, okay? So you will do these kind of things on your skill challenge, your labs. So you look forward to looking at that, installing memory, upgrading your video. You will do that. So make sure you know. And if you don't know, I can help you with that. But if you look at your demo, that will pretty much be all you need. Because the way they have this class interactive, they install that for your convenience. Okay, which components are involved in input, output? We already went through all of that. How do individual components work together? We know that. How? Number 2. How do they work together? What is connected? What's the thing that connects all components to the CPU?
Bus lines.
Bus. So I ask the question again. How do individual components work together? Through the bus. They communicate through the bus to the CPU. That's how they work together. On the bus to the CPU, that's how they are able to communicate with each other and work together.
Things like riding the bus to school or work.
Basically, exactly right. And that's the whole concept, and that's probably how they came up with it, I assume. I don't know if buses were around when IT was developed, but somehow they had to come up with that. Bus?
Yeah.
No.
They don't?
Nope. Just a bus, card or bus that, nope, it doesn't have no like, it's not an acronym.
We call it train.
Hey, don't confuse the people. Oh man, how would a malfunction in each component affect the system as a whole? We just already kind of talked about that. So if I have a computer that's going crazy and the room is hot or whatever, it affects the whole system because it's gonna eventually make the system slower, typically. And you wanna remove that thing that's causing the problem off the network, or either fix it, one of the two, or shut it down, shut it off the network, you know? Because the networks are intelligent now. At one time, if you shut one computer down on a network, depending on what type of strategy you use, like a topology, which means, topology, that's in a circular form, which is called a ring topology. They don't have a travel in one direction, so if one computer comes offline, it affects all the other computers on that ring topology network. But we'll talk more about that.
Think about it.
All right. So I think I filled you guys up with enough for today. So what we'll do, and we'll keep doing the same kind of way. When we come in for class on Saturday, we're gonna ask, you got any problems? You got your book? Because you're gonna fall further and further behind when you don't have that key. I understand, but you gotta make it urgent to get the book, because the longer you wait, the more work you gotta do to catch up. If I get the green light to catch you up on certain things, I think it's legitimate, but you gotta be, you gotta treat it as a priority and get it as quickly as you can, because we can't make you get the book, but, but you gotta have a sense of urgency to do that. Now, the next question I have is, do we have any questions about today? Anything you struggle with? Now, does this make more sense for those that have already ventured to look at chapter, I'm gonna call it chapter 3? If you have, then this is where Saturday is set up. So if what you've read so far doesn't match what you're hearing, you should have questions. And Saturday is the time to ask those questions. And those of you who asked questions thus far, thank you for those questions, because again, that's part of this learning environment to understand more about what you've already read. I set this up purposely having it due on Friday, so when Saturday comes, you can ask those questions. If you come and if it's due on Saturday night, no, it was Sunday night. If you do it on Saturday, then you have all these questions come Sunday, and you may not be able to get a hold of me. It is the weekend. So I'm just doing it like that, so that way you have the opportunity to take this time to ask those questions that you may have, or problems that you may incur or run into that you may not understand. I may not know the answer, so don't get it twisted. If you bring it to class, I might not be able to answer it, but 9 times out of 10, I'll be able to answer it. And then also, if I can't answer it, I got colleagues, I got people smarter than me. I try to surround myself with people that are smarter than me. You know what I'm saying? So that way I get a lot of answers to a lot of questions that I know they know. Especially for me with DJing, I'm just gonna call him a master DJ, for lack of a better term, because he's been doing it way longer than I have. And the questions I have, guess what? When I encounter them, guess who I ask? I ask him. I send him a text, whatever. Hey, you know about this thing, da. Like on point. He come back, you tried this, you did this, not that. Sometimes he give me too much information. But I'd rather have more information than not enough to solve my problem. Because in that way I can try the extra stuff, but if he gave me enough, one of those things work, I'm satisfied. Then now what happens is I'll try that extra thing, already worked. I'll try that extra thing to see what that does. So I expand my knowledge. Not just what I ask, but I expand my knowledge. And that's the point of this class. Ask those questions, expand your knowledge, especially if it's an area that you're not clear about or you don't quite understand. This is not there's no dumb question. The dumb question is the unanswered question, because that means you never know. and you don't get the answer. So sometimes I have you look it up here while you're in class, and then it's all good. So I ask one last time. Any other questions? We good? We clear? So then let's see. Let's see what I don't have. I don't want to say it. Help me. What it starts with a what? Okay, how you pronounce that?
Albie.
No, last name.
Oh, Nung.
No, I got you. Because sometimes I'll be like, man, I don't want to butcher this name.